we're gonna take this piece, this lovely piece, right there, and we're gonna build one like this. We're gonna design one like this, and we're gonna do it step by step. This is a rather simple piece to design, and I think it's a very good opportunity for anyone trying to learn how to do this to be able to do it. Let's go for it. And the first thing that we're gonna use for this type of work is one of the most useful tools that any mechanical engineer, not that I'm one, must have, which is a caliper. I got this one. It's rather a cheap one, but it does the job. It measures up to 100 of a millimeter, which is more than enough than what I need. I might have said that wrong. No, yeah, I think it's 100. So we're gonna move to the measurements. So first of all, we're gonna start designing it using what in Fusion 360 it's called sketches. It basically lets you design a face of the device that you are designing, and then from that face you can give a third dimension to it. So we're gonna start designing this face that you can see here, and then we're gonna try to give to it a third dimension. Let's create a new sketch in Fusion 360, and we're gonna set the top. So we're working from the top. We're gonna start by a circumference, and we're gonna measure here. Don't worry about the size of the gear. We're gonna get to that when we are designing the actual gear. Just make sure that you measure a little bit less than it. Sorry for those that are not using the international measuring system. I'm gonna do this in millimeters. So we're gonna measure, let's say 28.5. This is the first circumference that we made. If we click on D and then we click on the circumference, we can actually set a measurement to it. So this will be, for example, 28.5, and that is our first gear completed. Now we're gonna move to the next one. We're gonna measure again. Let's measure, for example, let's start from here. This one here, little I don't know how to call that. So that is 8.9, which is kind of like 9, but we have to take in consideration that anything that gets 3D printed usually requires to have a tolerance between the real model and the actual piece print. So I'm gonna take the 8.9 and I'm gonna make it 8.8 to give 0.2 of tolerance between the potential holder of this piece and the execution, the 3D printed version. Back to Fusion 360, we're gonna take this and we're gonna put the 8.7 here. So that's one of them. Let's measure the third one. So it has a little bit of here. That is 10 millimeters approximately. Another circle on Fusion 360 of about 10 millimeters. Then we pass to the next one, which is this bit in here. This is 10 millimeters. Take it or leave it. We could do another one, 10.3 maybe. Let's see. Back to Fusion 360, 10.3. Now let's make this little one, which is also 9. So we're gonna leave just like that because we already have that measurement. And then we're gonna take this gear and try to measure without counting the teeth. So try to measure the thickest part. The reason is that we are gonna do a cylinder to support the gear, but then we're gonna design the gear in a different using a different system. So this will be somewhere between 10 millimeters. So since we already have that measurement, we don't need it. So now that we have enough measurements of this, let's try to make some sense of the sketch that we recorded on Fusion 360. So now we're gonna take this, we're gonna finish this sketch, and you can see that this sketch only have 2 dimensions at the moment. We're gonna start moving things around. So this, for example, is the big gear, and we know that the big gear is about 5 millimeters thick. So we come here and we specify that we want this gear to be 5 millimeters thick. This our sketch is automatically hidden, but you can show it again because we still have more measurements to use from this sketch. Since this gear is thick, although it has a hole on it, we're gonna make it thick instead to make it a little bit stronger. Probably not needed, but it will make sure that the printing is much more strong. So we're gonna take these 3 sections, we're gonna click extrude, which is the E, and we're gonna tell it to extrude to an object, and we're gonna click on this face, and that will fill the hole. Now we have the base for the first gear. We can start measuring on the sides and get to a point where we have some form of something that makes sense. So in order to measure this part, there is this lovely tool in the caliper, which is a measurement to measure the height things. You can see how this little thingy gets out. So you can put this on the top of it and measure until it touches something like that. There we go. And it says 590. So that's going to be about 6 millimeters. So we're gonna take this measurement and make a 6 millimeter thingy. We're gonna take the 3 of them. We're gonna make this -6 millimeters. So we're gonna take the opportunity to do this using measurements instead of just what I have done so far. So if you go to modify and go to change parameters, you will see this screen in which you can actually use user parameters to create measurements that will be used across the whole design. So for example, we can use here big gear diameter thickness, I don't know how to thickness, and we knew that this was 5 millimeters. So if we check the extrude operation that we did, which is this one, instead of using 5 millimeters, we can type here big gear thickness. Ta-da! And it's the same, isn't it? It's just same boring old gear. It is, but if we hide the body and we click in here, make an extrude of it, we can tell the extrude to be big gear thickness plus 19 millimeters, which is what we expected. And then we can show the body and make a join, and this will be it. The good thing about this is that if you change this parameter because, for example, you made the measurement wrong, you can simply change it, and everything, the whole design will update automatically. Like for example, imagine that gear instead of 5 millimeters was 4 millimeters. You change it, and everything that is using this measurement, this parameter, will automatically update. Super useful to do designs that are complex. 5 millimeters. There we go. So now let's move to the next one. The next one was a little dent. Let me see if I can show you a little dent in this side. This one is kind of hard to measure, so I'm gonna use this instead. If you support yourself there, you can measure more or less how big it is. Unfortunately, it's too small, but if we move it a little bit like this, it should allow us to measure more or less something, somewhere in the 4.75, I will say. So we're gonna make that little dent now. We're gonna select the sketch, which is this one, and we're gonna do an extrude. We're gonna show the body again, and we're gonna use the same formula: big gear thickness plus 475, and this is going to join the current object. Ta-da! And now the last thing that we will have to do is this one. This one is about 7 millimeters in the direction, which is the total of this from here to here, minus 7 millimeters, which is 19 millimeters minus 7, which is 12 millimeters. And the thickness of it is another 7 millimeters. So I think I already said that. Anyway, don't pay too much attention to me. So now that we have it measured, we're gonna take the measurement, like select the sections, click again on extrude E. Although just so you know, you can use the option S, which allows you to search anything, and you can click in here, you can type in here extrude it, and it will allow you to do the same thing, just in case you don't remember what was the name of or the hotkey of one of the tools. So now we're gonna show the body, and you can see that this is not what we want. It doesn't look like it, isn't it? So instead of doing a one direction extrude, we're gonna click on second, two sides, and then we're gonna click on this side, which I think is the 18 millimeters, yeah, and we're gonna change it to object, and we're gonna click in this object, and that is going to be the limitation of that one. And for the other side, we're gonna use the distance, and we're gonna take this one from here to here, and the total was 24 millimeters, so we're gonna take minus 24 plus 7, which is the thickness of the gear that we were expecting, and that is our gear. Well, that is the holder of the gear. If we click on OK, that is looking getting there, isn't it? Now we just need a couple of gears. This is where the work, let's save the project. This is where the work gets interesting. Fusion 360 has a tool to make gears, which is pretty handy, and it requires you to do some work. I'm not a professional on this, so please let me know if I've done something wrong, but I kind of try to do it by hand because I don't have the original measurements of this. Maybe there are better ways of doing it. The first thing that we're gonna do is to measure how many teeth we need. So this one is 15 teeth, small one. Let's start designing that one. So if you go, well, actually, before we go, let's measure approximately what is the pitch of a gear. The pitch of a gear is the measurement of the circumference in the middle of the teeth. Like, for example, the teeth has a length, so the middle part of the teeth is called the pitch, which is where the other teeth will click, will match, and the pitch is useful because it allows you to measure how close the other gear is going to get to yours. So it's really hard. I don't know how to measure it better, but what I do is try to measure more or less by hand the half of it. Like in this case, for example, let's say it's about 12.2. So we have a 15 teeth gear with a 12.2 of pitch. So we go to Fusion 360 and we click on the S and we search for scripts. There we go, that makes sense. Click on S. We find the scripts. Let's try with the Python one. So we will have 15 and the pitch diameter we know is somewhere on the 12.2 millimeters, which means that we have to reduce the module until we get there. 0.9, 0.6, 0.7, 0.8. That will be. And now it's saying that our hole, center hole is too large. Let's remove the center hole then. The root fillet radius is too large. Let's make it 0.48 as recommended. And that is our first gear. I'm gonna take a screenshot of this. On the hole, we're gonna make it another 5 millimeters. So this should hopefully look much more like what we are looking for. Okay. So this is the new gear. Let's make a joint between the body and the new gear. We can click on S and then click on joint. We define the origin of the first one, like here, and then we want where we want to put it, which is here, and it magically moves. If we move it a little bit, we can make it match. And I just remember that this gear was not 5 millimeters, but 7. So what we can do is take the body, take this face, and extrude this face another 2 millimeters. So now, hopefully, we should have the gear and the support for it. That's the reason why we make the support slightly, to make sure that, oh, look at this. This support was too big because my measurement was wrong. Because if we see a transversal cut of this field, of this section analysis of it, where we'll see that the thickness of the support that we created is torpedoing my gear. So we're gonna undo this section analysis. We're gonna take the gear out. We're gonna take this face. I'm gonna click on push. We're gonna apply a press pull. I'm gonna take away maybe 0.5 millimeters. And now, hopefully, all gear should sit perfectly on it. Excellent. That looks much better. Now we have the big gear. Big gear is it's a pain in the arse because you have to count all the teeth and you have to do them very efficiently. 50 teeth, exactly, which is nice. So we're gonna do the same thing that we have done with the other one. We're gonna measure the outer part of it, which is going to be around, the total is 32.2 and the teeth is about, oh, I can't measure this, it's just too small. The teeth is about 1.68 long, 1.50 long, which means that instead of 32.2 we're gonna use 31.5. Take your living. Obviously this have to be measured properly, but this is just an example of how to design something. Right. Let's open that lovely gear plugin that most of the times fail. Spur scripts, and then spur gear, and we're gonna do the same thing. We're gonna put the teeth, 50 teeth. We're gonna adjust the module so that the pitch goes to around 31.7, 31.5 we say. So 31.5, 0.63 exactly. The thickness of the gear is exactly 5 millimeters, which is the one that I measured earlier by mistake, and the diameter can be 5 millimeters too. And the root fillet is too large, it has to be less than 0.37. Let's change that. And that's it. I'm going to take a screenshot of this just in case we have to repeat the process. And that's us, new gear. We're going to repeat the process that we have done earlier with, let's take this body away, let's make a joint. Let's measure the joint. If you have a problem finding the center of a gear because it has a hole on it, one trick that you can use is to position yourself on top of the gear, click the control key, and then automatically you are allowed to use the gear position again. So that is one, and then the other part in which we're gonna put it is here, and then our gear magically moves to it. And now we just need to adjust it to match exactly. If I click in here, will it make a difference? No, but if I click in here, yeah, that looks much better. So this is our gear. It kind of looks like what we were designing, isn't it? There are a few modifications that I will do to be able to print this properly. One of them is to use a fillet here, if I am allowed. There we go. This will make the surface curved so that the angle in which it's going to be printed is much softer, and you don't need much support to print it, and it will also give a little bit of strength to the gear. And you can also do this in here on a slightly different tool. Instead of using fillet, we will use chamfer here, and you chamfer this 0.5 millimeters, maybe 0.3 millimeters, 0.4. Would you allow me 0.4? No, 0.30. Oh, 0.35 maybe. No, 0.3 is as much as you get. And that will create a little bit of surface so that the printing is much more smooth. So if you're gonna print this from this position, as you can see, that will help a little bit the filament to settle properly. And this is it. This is our first piece. If we take the sketches out and we go to the render section, we can make something nice of it. I hope you enjoyed this tutorial, and I'll see you soon.